Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
Let's move for type 7 NSS LSA. So if you talk about type 7 LSA, so type 7 LSAs will be used to allow external prefix or external routes through understood. Rest of the things will be discussed during practicals only related to type 7, because it is not really important to discuss it right now, but later on during practicals I will explain it to you in more details, right? But the thing is, like in NSSA LSA, I mean in type 7 LSA as well, link ID will be your external prefix and advertising ID will be router ID of an ASBR. Hello, right? Now, types of areas. In OSPF, 1, standard area, stubby area, three totally, standard area. By default, all areas are standard areas. All areas are right. By default, all areas are standard area. They allow all types of LSAs. There will not be any problem, right? So by default, all areas are known as standard areas. Now stubby area, like if you do not want to allow external prefixes in your area. For an example, if you do not want to allow your external LSAs, type 5 LSAs in your area, then you can define your area as a stubby area. But remember that you cannot configure area 0 as a stubby area. You cannot configure area 0 as stubby area. Second thing, virtual links are also not allowed in a stubby area. Remember, virtual links are not allowed in a stubby area. You can use only one thing. Either you can configure your area as a stubby area, or you can configure virtual link. यो
अगर हम जो एरिया सॉरी राउटर 4 है
R1, R2, R3, R4, R5, area 0 and area 1. Now on R1 you perform some redistribution, so it became as, so it will give all those. Let's say that you have redistributed 500 prefixes now, 500 prefixes. You understand? So let's say that you have redistributed 500 prefixes onto R1 now into OSPF. So it will generate 500 type 5 LSA. It will give it to R2, R2 will give them to R3, R4 and R5 as well. So all routers in area 1 will also have all those LSAs available inside their database table as well as routing table. Fine. Now you observe that R3, R4 and R5, the performance of all these three routers, R3, R4 and R5, again repeating, R3, R4 and R5, the performance of all these three routers is not good, is very down. And you observe that it is happening due to lack of memory. It does not have sufficient memory now, because it is already having a huge database table as well as a routing table, right? Now you can solve this problem by replacing your devices. You can replace your devices with higher hardware configuration, so there will not be any problem like that. But it is not really easy to replace your devices in your existing network. It's not really easy. Even budget will not allow you to replace your devices very easily. So to solve this problem, you can define this area 1 as stubby area. What will happen if you configure this area 1 as stubby area? Because you know very well that type 5 LSs will not be allowed in stubby area. So now, because you are having 500 type 5 LSs, so R3, R4 and R5, they will not have those external type 5 LSs inside their database table. And if they do not have type 5 LSs available inside their database table, then how will it be possible for them to have them inside their routing table? Are you getting my point or not? So if they do not have those type 5 LSs available inside their database table, so that they will also not have them inside their routing table too. And if they do not have them, if they do not have these LSs, these external LSs, so of course, and also they do not have those routes available inside their routing table. So what will be memory utilization now? Means that the memory utilization will be reduced now. And if you have reduced the memory utilization, it means the overall performance will be upgraded now. And now if they do not have external prefixes in their routing table, so will it be really possible for R3 and R4 to communicate with the external users? Of course no, because they do not have any external prefix. So to solve this problem, actually what happens that if you define any area as a stubby area, then ABR will also be responsible to inject a default route. So this time what will happen that R2, because R2 is working as an ABR, so R2 knows very well that area 1 has been configured as a stubby area now. So it will be responsibility of R2 to inject a default route in the database table of area 1. So that all routers like R3, R4 and R5, they will be responsible to receive a default route coming from R2. So with the help of the default route, R3, R4 and R5 can still reach those external prefixes. But remember that default route will not be available in the routing table of R2, because R2 is already having all those external prefixes inside their routing table, because R2 is also participating in area 0 and you cannot configure area 0 as stubby area. So those type of LSs will not get filtered from area 0.
In this case, how many type 5 LSs would be generated if we have 500 prefixes?
500. Remember, if you talk about the external LSs, for one prefix there will be one LSA. If you talk about summary LSAs also, there will be one LSA for each prefix. It means that if your router one router LSA is having 10 links information, ABR will break that router LSA into 10 different summary LSAs now. So remember, one summary LSA can have maximum one prefix information, as well as type 5 LSA can also have maximum one prefix information, as well as type 7 LSA can have maximum one prefix information. So as per number of prefixes, you will be having number of LSAs. So if you are having 500 prefixes, then definitely you will be having 500 external LSAs. If you are having 500 inter-area prefixes, it means that you will be having 500 summary LSS. Because inter-area prefixes will always go in the form of summary LSA. Inter-area prefixes, right? Any problem? Sure. Good. In same manner, we are also having totally an SSA. Actually, what happens that after defining your area as stubby area, it will filter only and only type 5 LSA. Along with type 5, it will also filter type 4. Because if there is no type 5, then what will you do with type 4? Try to understand technically. If there is no type 5, what will you do with type 4? That is why along with type 5, it will also filter type 4 after defining a stubby area. But still, it will be receiving inter-area prefixes. Let's say summary LSAs are also huge. Number of summary LSAs are also huge. And number of inter-area prefixes are also huge. So still the performance of R3 and R4 and R5 is down. So what will you do now? You can make it as totally stubby now. Once you will define your area as totally stubby, it will start to filter type 3, 4 and 5, all these three types of LSAs, and in place of all these LSAs, it will again, your ABR will be responsible to inject a default route. So there will not be any problem with the help of, there will not be any problem if you do not have any external or inter area prefix in your router's routing table, because they will be having a default route, but that default route will be injected by an ABR only. So still R3, R4 and R5 can communicate with external users as well as inter-area users too, with the help of default route. So this time, of course, area 1 will be having only and only intra-area prefixes, only intra-area. And in other words, I can say that these types of areas would be used to filter your LSAs only. Like you are saying that stubby area, totally stubby area, NSSA, totally NSSA. So all these things will be used to filter your LSAs. It's kind of filtering actually. I'll be discussing all these things during practicals, that okay, this is kind of filtering, and actually it is filtering, because by performing filtering we are enhancing the performance of of all those devices which are participating in area 1. But remember that ABR must have very good hardware configuration, because on ABR you cannot perform filtering. ABR must have very good hardware configuration. However, generally we prefer to configure single area OSPF in the networks, but in case if you are having a huge number of routers available, huge number of devices in a single network, then of course it will not be a good idea to implement only single area OSPF over there. Because if you are implementing single area OSPF, again, because I have already discussed it with you, right? There will be too much CPU utilization due to SPF algorithms, because whenever there will be any change in your network, every time your routers, all routers in that area have to run SPF algorithm, right? So to solve that problem, actually we can implement multi-area OSPF. Have you understood it all?
Yes.
Good. In same manner, we are having NSSA, totally NSSA. I'll be discussing the uses of NSSA and totally NSSA later on, right? Now let's talk about types of authentication, and I hope I have already taught you types of authentication. Here we are having three types of authentication: 0, 1 and 2. 0 is what? Null. 1 is plain text, and 2 is what? MD5. Achha. Right? So these three types of authentication are available in OSPF. Now latest iOS have also started to support SHA. Fine. After it, let's talk about types of summarization here. In OSPF, it supports two types of summarization: internal and external. Internal summarization can be done for inter-area prefixes. External can be configured for external prefixes. Internal summarization can be configured only on ABR. External can be configured only on
If you do this summarization with the number of LSS, it will decrease.
Exactly. Otherwise, what will be an advantage of configuring summarization, right? That is why here we are having only these two spots where you configure summarization. Because on ASPR, of course, it will be responsible to generate type 5 LSS. So if you are configuring summarization on ASPR, it will reduce total number of LSS too. Like if you have summarized 7 networks together in a single summary address. Previously, it was generate 7 external LSA, but this time it will generate only
One LSA.
one LSA for summary route only.
Okay.
And in same manner, like ABR will be responsible to put your routes from one area to another area. So when routes goes from one area to another area, then it will break your router LSS into summary LSS. So if your router LSA was having like 10 links information in a single LSA, then it will break them. I mean, it will break that router LSA into 10 different summary LSS for different areas. It's not it. But if you have configured summarization on ABR for multiple prefixes, I mean, if you have summarized multiple prefixes together in a single prefix, then it will generate only one summary LSA for your summarized route only. That is why in OSPF summarization can be configured only on ABR or ASPR. Because ASBR would be responsible to generate type 5 LSS, whereas ABR would be responsible to generate type 3 LSAs. Because whenever routes will go from one area to another area, they will always go in the form of type 3 LSA.
database exchange प्रोसेस में देखा है कि एक एक करके नहीं वो इकट्ठी भेजता है.
Yes, in a single update you can have multiple LSAs. That is LSU, not LSA. Inside one LSU you can have multiple LSAs.
So instead of this stubby and totally stubby,
You can also use summarization and all this stuff. But let's say that you are not allowed to configure summarization.
Okay.
You can also do it. Tell me. If you are having any other issue here in OSP, please let me know. What खत्म हो गया? सभी हैं. All are available.
जब स्टॉक ऑथेंटिकेशन फिर उसका क्या होगा?
शाह भी है. टाइप नहीं है. There is no type for SHA authentication.
It's available only in 15.
Exactly. Now let me show you LSA. In previous class I shown you router LSA. Today I will show you network LSA itself. 210. Network LSA. You see? Is not it? That's what I said. In a multi-access network only. Network LSA is originated by the DR only. The LSA describes all routers attached to the network. The LSA's link state ID field lists the IP interface address of the first 20 bytes will remain same, and then after network mask is there and attached routers are there. Then you have summary LSA. Now in summary LSA you have two types of summary LSA. One is type 3 and type 4. One is normal summary LSA and one is ASBR summary LSA. So that's what they said here. Summary LSAs are type 3 and type 4. These LSAs are originated by ABR. Summary LSAs describe inter-area destinations. Type 3 LSAs are used when the destination is an IP network. In this case, the LSA's link state ID field is an IP network number. What I said in type 3 LSA, right? So when the destination is an ASBR, then type 4 summary LSA is used. Link state ID field is the ASBR router ID. Hello. When the destination is the ASBR router, the type 4 summary LSA is used and the link state ID field is the ASBR router ID. So if it is type 3 LSA, then under link ID it will be having network number, prefix, your network ID. And if it is type 4 LSA, then it will be having router ID of an ASBR under link ID. And this is type 3. First 20 bytes will remain same. Then after you are having network mask, metric, and all these things. That's all. Type 5 external LSA are the type 5 LSAs. These LSAs are originated by ASBR only and describe destination external to the AS. It means it will be having only and only external LSAs. Up to here it is same, first 20 bytes, and then after like network mask, metric, forwarding address, external route tag, TOS metric, forwarding address. So all these things are there. Right? This is all about type 5 LSA. Now let's move back again on okay, it means that in summary LSA we do not have any bit, but in type 5 LSA we are having a bit E bit is there, and this E bit will be responsible to tell you, you see, external metric. If E is set, the metric is specified is type 2. This means the metric is considered larger than any other, and if E is 0, it means it is type 1 external. So this E bit will be responsible to specify whether this is type 1 external LSA or type 2 external LSA, because your external route will come as either type 1 or type 2. So this E bit is always there inside type 5 LSA to specify whether it is going to be type 1 or type 2.
External route tag.
Fine. So this is all about LSAs, all LSAs. Type 7 LSA is not available inside this RFC. Right? Fine. Now that's the end of the OSPF theory now. Okay. So let me explain you network types as well in OSPF. So in OSPF we are having some network types. Some network types are Cisco proprietary, some are open standard. But let me create one here, like one table in which I will specify your network type and their properties, right? So let's say this is network type. Hello interval, dead interval, DR and BDR election. Default priority. Dynamic neighborship. I mean, neighborship can come up dynamically, right? Dynamic neighborship. And finally, will it be possible for you to configure neighborship statically? So static neighbor. So all these options are there. So as per network type, I will specify it. First of all, point to point. Hello interval is 10. That will be BDR election will not be there. Default priority is 0. Dynamic neighborship will be formed. Static neighbor cannot be configured. You cannot configure the neighbor statically in case if your network type is point to point. Next is broadcast. Again 10, 40 BDR election will be there. Default priority will be 1, and dynamic neighborship will be there. Of course, it will be there. Hello. Now you see dynamic neighborship will come up. Static neighbor cannot be configured. Third, point to multi-point. P2M point to multi-point 30.
स्टैटिक नेबरशिप सब कॉन्फ़िगर वैसे तो कर ही सकते हैं.
इस नेटवर्क टाइप में नहीं कर सकते. Point to multi-point 120. BDR no. Default priority is 0. Dynamic neighborship will come up. Statically cannot be configured. You cannot. If you want to configure your neighbor statically in OSPF, then you have to change your network type. Now I'm going to explain it.
By default, internet का
Point to multi-point non-broadcast.
broadcast भी होता है सर.
Let me complete it first. अच्छा कर लेना आज. Point to multi-point non-broadcast 30, 120. BDR election will not be there. Default priority will be 0. Dynamic neighborship will not come up. And you have to configure your neighbor statically. Have to configure. There is no other option. And if you have your network type as non-broadcast, only non-broadcast, hello will be 30, dead will be 120, BDR election will be there, default priority will be 1, dynamic neighborship cannot come up. I mean, neighborship cannot come up dynamically. You have to define your neighbor statically. And you cannot change their behavior. If you cannot configure your neighbor statically in point to point, means you cannot configure it. And if you want to really configure your neighbor statically in OSPF, then accordingly you have to change your network type. Either point to multi-point non-broadcast or simply non-broadcast. Fine. So these are the default things of these are the network types actually, and this is all about the network types. Like what are the default timers, what are the default priorities, BDR election, neighborship will come up dynamically or not, can you configure static neighbor or not. I mean, all these things are there. Another network type is also there, which is known as loopback, but network type loopback can be configured only on loopback interfaces. Remember, network type loopback can be configured only on loopback interfaces. And if your network type is configured as loopback on loopback interfaces, this is by default. So in that case, your loopback will always be advertised on /32. Understood? Now, let me tell you some other things here. If your interface is serial interface, point to point, then by default your network type will be point to point. If your port is Ethernet, it will be broadcast. I mean, in case of SDLC or PPP. If you are running either SDLC or PPP on your serial interface, then by default network type of OSPF will be point to point. On Ethernet, for all Ethernet ports, by default network type will be broadcast. For frame relay interfaces, it is by default non-broadcast. Right? Fine. So that's the end of the theory of. Remember that if you are having discontinuous areas, discontinuous areas means something like this: R1, R2, R3, R4, R5. Let's say in between R1 and R2 you are running area 0, between R2, R3 and R4 you are running area 1, between R4 and R5 you are running area. Now of course this is called discontinuous area. So area 2 is not directly connected with area 0, it means area 2 cannot communicate with any other area. So in that case you will require to configure here virtual link. However, I can solve this problem without using virtual link as well. Like I can use GRE tunnel to solve this problem, or I can perform redistribution here. In OSPF, I can solve this problem without using virtual link as well. But the best method is virtual link to achieve this task, right? I'll let you know that what are the disadvantages of configuring other things, of configuring other solutions to solve this problem, right? That's why we generally prefer to configure only and only virtual link to solve all these kind of problems. But remember that if you are having this type of network anywhere in the in your network, then you have to configure only and only virtual link. But also remember one more thing here, that virtual links are simply like temporary solutions. You can use virtual link as a temporary solutions. You cannot use virtual link as a permanent solution. It will be better for you to connect all regular areas with backbone area. But for instance solution you can use, I get your point, virtual link. So with using virtual link you will be extending area 0. But now I will teach you virtual link during practicals only, because in virtual link I have a lot of things to explain. A lot of things are there to explain in virtual link, but this time in only theory we cannot discuss all those things, right? It will be better for us to understand all those things along with practical, so that you will understand all those things easily with practicals. It's not it, because if I am saying to you anything like, okay, virtual link works in this way, so at that same moment I will also show you that, okay, technically see this is going on in the background of this virtual link, and this is working in this manner actually. Fine. So now
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.